Hey everybody, welcome back to Amateur Hour. I was going to show you this thing taking its first steps, but there was a mishap. Ah, fuck. One of these things is not like the other. Yeah, so the SSOP 20 package that this PIC microcontroller comes in turns out to not be the same size as the SSOP 20 footprint that is in KiCad. That's what I get for trusting but not verifying. I've already gone looking for my wire wrapping wire, can't find it, so I can't even get it dead bugged in here. I know what you're thinking. We already know you're a screw up, but what the hell is this thing supposed to do? This is intended to be a heating element control board so that I can do things like control reflow soldering or heat treating for steel or even like foundry stuff. As for the strategy here, I'm just using a triac to trim the waveform. It's kind of a pretty standard way to do current limiting on AC power. Basically, coming out of the wall at 60 Hertz is your waveform. That's the electricity coming out in AC. What I'm doing is I'm detecting the zero cross of that waveform. Then I'm allowing the current to pass and cutting it off once I've let as much of the waveform through as I want. So if I only wanted half the power to get through, I'd cut it back here or a quarter or so on and so forth. It's a little bit more involved than that, but that's enough to get you started. I'm using two AC optocouplers, one to detect the zero crossing and the other one to control the triac. The zero cross I'm using is a PS2815-1. The one I'm using on the triac control side is a FODM3022 R2V. Up here's where the thermocouple goes. I've got one of the little thermocouple connectors, and I've also got a hookup for a little IC that interprets the voltage coming out of the thermocouple and then converts it to a value and sends it over I2C to my microcontroller. I haven't soldered that down yet. Fortunately, I realized my mistake back here before I got to this part, because this is actually the most expensive piece. Both the connector and the interpreter IC are both pretty pricey for as far as electrical components go. I'll see how well I can get some lines patched in over here and running over to a breadboard, and if they look like good connections, then I'll go ahead and hook these up. But otherwise, I'll probably have to run a new board, which is a real pain in the ass. So there's actually a repository up on GitHub for this board. It's very dangerous. I would not use this board. This is a really rough early prototype. There's not any protection on it. All these are, there's a lot of dangerous shit on this board, so I would not suggest that you make a run of this and try to use it. I'd like to get a more production worthy board up later that people would be able to make a run of and use on their own, but you can tell from the soldering that I'm a software guy, so yeah, probably not a great idea. Anyway, just wanted to give you a quick preview of something that was coming down the pipe. Thanks for watching.